coming towards the end of the Premier League season, but who is going to win the title and who is going to be relegated? Can maths give us the answer?
Stay tuned to find out.
Welcome to the Corridor of Uncertainty, the podcast at the intersection of maths and sport. I'm Jess.
And I'm Rich.
We're both mathematicians at the University of York who spend too much time talking about sport, so we thought we'd make a podcast. So, what are we talking about today, Rich?
Well, Jess, it's coming. Premier League's currently on an international break. It's FA Cup this weekend, so there's a bit of gap in the Premier League. So I thought it'd be a great chance to predict what's going to happen for the rest of it, and to see how maths can answer this question as well.
Excellent.
So I don't know about you, but there's always see these clickbait articles that are saying supercomputer predicts the end of the league, predicts the league winner, this sort of thing. And it always makes me laugh a little bit because it says supercomputer. And the things we go through today are probably the same method they're using. And it takes about 2 seconds to run on my laptop. So you really don't need a supercomputer to run all these calculations.
Okay, big talk.
But we're probably going to go through the model today that most of these places will use. And it's kind of the classic football model that a lot of places use. Perhaps, the Opta supercomputer uses a fancier model because they've got a lot of stats. But it will all be based upon this model that we're talking about.
Well, we'll see. I think I know what you're going to tell me use as the model, but I don't know. But so when I was talking to some people who work for betting companies, and we in no way endorse gambling on the Corridor of Uncertainty, but they're doing exactly what you're trying to do. They're trying to accurately predict. And, in our world, people do try and use, mathematical models to try and predict football. And it's hard, but the betting industry does a good job, right? They're still there making money, doing well. And so I was trying to ask them what methods they use, because is it a supercomputer? Is it crazy beyond what anyone is doing in a university? And they sort of said, it's similar to what you'll be doing. Yeah. But they have lots of data that they can buy. Yeah. And they also have the data of what the people are doing. Yeah. And Asian markets and so on and so forth. So, like you said, I don't think even the actual gambling industry is using like massively supercomputer heavy intensive stuff. But anyway, we'll talk later a little bit around how these about bookies as well will come up later too. Yeah. But if we're predicting stuff as a mathematician, we need to think about what we call a probability distribution. And that's maybe not, that's a word probably you say every day, but it's not something that everybody would know. So I wanted to go through very briefly kind of what they are. Okay. And it's like, if we're tossing a coin, most people know that's a 50-50 chance. So that's already a probability distribution. You would say each one has a probability of 0.5, 50-50 chance. That's what we can say for one outcome, tossing a coin. If we do it 10 times, we need to kind of build a bit more understanding into that. We need to know that, say, heads is, if we do 10 tosses of a coin, heads is going to come up around 5 times. But it's not definitely going to be 5 times. On average, it'll be 5 times. That's the most likely thing to happen. But sometimes it will come up 10 times. Sometimes it won't come up at all. We need to be able to assign a number to all of these possible outcomes in order to say what's going to happen. And we use a probability distribution. The one for tossing the coins is called the binomial distribution. And this is kind of classic probability distribution. It is just literally building up that, like if you wanted to see 5 times tossing the coin and getting heads in 10 goes at tossing the coin, how many ways could that occur? And it counts them all up and adds them together. So that's the simplest kind of probability distribution. That's probably the one you first learned, is it? Yeah, but yes. But I think when you start thinking about what you've just said, that's kind of A-level maths. Yeah. So it's not like, you are quite advanced when you start learning these things.
Yes. Yeah.
Have you seen that one where Derren Brown, like a magician, illusionist, psychological illusionist, does a show. And part of it is he's saying, look, I'm amazing. I can tell you that this coin is going to do 10 heads in a row or whatever. Yeah. Or 20 or 30, something like that. And he flips the coin, right? And gets exactly what he's just said. And then, you watch the whole show and then he sort of tells you about how he's done everything. Right. And then at the end, and he's like, basically, we just filmed me doing it until it happened. And so they showed you all the outtakes.
Yeah.
And I think the excellent one is when he's like on 29 or whatever it is, and they've been doing it for hours and hours and hours. And he's like having to hold in and pretend that he's not done this for hours and hours and hours, and it's just the first time. And yes, of course, this is the 30th one. So yeah, it's brilliant. But it's exactly what you say. Like that shows that.
Well, if he'd known the probability distribution
he
better,
would have been able
he could have
to
calculated how long it would have taken.
Yeah, estimate how long it's going to take.
Actually, how long is an important thing here, actually. So what we're stepping to, because the binomial distribution, this one for tossing a coin, can't predict football outcomes because clearly football matches are more than just a coin toss.
Yep.
They need, yeah. But what if we were to say Darren Brown is tossing a coin 100 times an hour, how long will it take him to get a certain amount of coin tosses, a certain amount of heads in a row? That's more like something we would model with the Poisson distribution.
Okay.
So the Poisson distribution is like, the classic example for it is like cars driving over a bridge.
Okay.
That's kind of one of the classic examples of it.
Really get the kids interested in maths with that example.
Well, so it is.
But we're going to say, because we're going to give it football, yeah.
But you're waiting, and you say, there's 3 cars per hour on average, say, how long do you have to wait to see 10 cars, or what's the chance of seeing 10 cars in 1 hour? That's a lot like goals in a football match.
Yeah, so it's like where you've got rates of something occurring and windows of time that you could extend, or, like you say, hours, 2 hours, half an hour.
Yeah, so it's based on rates.
Yeah.
And in the case of football, we'll look in a moment about goal scoring rates.
And you're counting something as well.
Yes.
So it's a whole number. Yeah.
Yeah. So we used the Poisson distribution. It was invented by Simon Poisson. I'm not sure how you say it. He died in 1840, so 22 years rather, even before Notts County. So he probably wasn't thinking about football when he derived it.
You never know.
It was used. So I'll pop the equation up on screen. Basically, the rate of something here is lambda. The K is the number of times we expect we're looking for. So if we're looking for 5 coin tosses in an hour or 3 cars in an hour, that's the number we would use. And X equals K. This is the common kind of way we have for probability distributions. That just means we're looking for the probability of K number of events.
Yeah. So the probability that number of goals equals 2 is, and then you plug the number 2 into that equation, our rate, so whatever my goal scoring rate is, and that would give me a probability of scoring 2, and I could then calculate 3 or 4 or 5 or anything I wanted to know. Yeah.
So one of my favourite uses of it, though, was not football, was that a guy whose name I'm not going to try to pronounce calculated the frequency with which soldiers in the Prussian army were accidentally killed by being kicked in the head by a horse. Wow. So he used this because it's about like how many people per unit, and then you say what's the chance of it?
Okay.
Yeah, so kind of unusual use, but it's adaptable probability
distribution. That's a real insight into someone's life, isn't it? That's the thing.
Yep.
Okay.
Yep. Well, I say this is still useful to calculate, I suppose.
Well, yeah.
So since the 1950s, because of this like distribution, the way it's structured, it's about rate of things, immediately kind of fits well for modelling football because you're talking about how many times a team scores a goal per game, and that's why it's going to work well for football. It's just, you take the average number of goals in a game across a whole season and then say, given that, we use the Poisson distribution to say how many times did a team score 1 goal, how many times did a team score 2 goals, 3 goals, 4 goals, and so on. So this data that we're showing on screen now is actually the 2025-26 Premier League season so far.
Okay.
The average goals per team per game is 1.37. So that's per team. So that's not per game. That's each team scores this.
Okay.
And then I've fitted it to the Poisson distribution. So I've taken, you can see it's around 200 times that there's been 1 goal scored in the game and so on by a team. You can see actually it fits pretty well.
Yeah.
So the probability distribution will give a number between 0 and 1.
Yeah.
But in this case, I've scaled it by the number of games. So there's 309 games in this data set. You can see it fits pretty well.
Oh, yeah. Okay. Yeah.
So it doesn't fit perfectly, but it does describe pretty well what we would expect to see for football.
So the distribution is that grey line.
Yep.
and the underlying data is the bars. Okay, so yeah, like we say, it's going to be under in some places and so necessarily over in others. But yeah, it's getting that shape that it's sort of peaking at.
Peaking at just below the average, and then you're going to see a tail where you see score more, and that's one of the important things. Like you're saying about counting things, is you need to have like a zero part as well, and that's different to the Poisson distribution. So as I say, since the 50s, Charles Reap, the father of football statistics, as he probably likes to be called, had shown this works pretty well. There is another distribution that they used actually that fits a tiny bit better, but it isn't to do with kind of how it fits it doesn't apply to a game in the same sort of way.
Okay.
So the Poisson distribution is good for describing how many goals per game in a football match. But to use this to describe the results of a football match, we need to build in a bit more understanding.
As in who's going to win?
Yeah, as in who's going to win.
Yeah.
Well, because we know we can use it to model how many goals you would expect a team to score in a game.
Yes.
But we've got two teams
Yes.
playing, basically. So we
Yes.
need to consider both of those at once.
Yeah.
So Maher, in 1982, developed a model that's known as the double or the independent Poisson model.
Okay.
And this is where you have both teams, there's numbers in there, and it will give you, you take the rate of chance of scoring goals and then gives you an expectation of like, is it 3-0? Is it 4-0? Is it 1-1? Is it 2-2 and so on? So it gives you a probability for each outcome, or because for each Poisson distribution, you get a probability of how many goals they scored.
Mm-hmm.
And then with two teams in a double or independent Poisson model, you'll get a probability of how many goals each team scored. And from then we can predict the winner.
Yeah. So it's
just
like...
to say in football, the team that scores the most goals wins.
Oh, yeah.
Just to be clear. Yeah.
So it's reminding me of, again, maybe back into GCSE high school maths, where you would have, it had a name, a sample space diagram, that's like a two-way table. That might be two things that are going on. So I might be rolling a die and flipping a coin. And then in each box, it could be like head and 1, head and 2, head and 3. And you can work out probability of the head and the probability of the 3 on the die. So they're independent, so I multiply them together and I can put a little probability in that box. And then you could have, like, you're saying, if I've got football team, probability of 1, 2, 3, 4 goals, 1, 2, 3, 4 goals. Independent, so get a probability of a 1-0, a 0-1 might be different. And then there'll be zones of that table that would be Leeds winning, there'd be zones of that table that would be
Man City winning.
City winning.
So, but we will see. We'll have a look at one of those in a moment.
Right, okay, brilliant. Got it. So it's like we've got one of these Poissons for each team.
Yeah.
And then we're combining them like we used to do it.
Yeah. So like a really simple model would say each team is going to score the average number of goals.
Yes.
That's still going to give you probabilities of
all the different
results.
Yep.
But over the course of a season, and over the course of repeated simulations of a season or a game, it's going to say that everybody draws because every team is scoring the average number of goals.
Everyone's being treated the same. Yep.
So what Maher did is adjust that on the basis of the data that he had from multiple years of Football League play, and it kind of adapted that model. So these equations we've got on screen are how he's adapted that.
Okay.
So these look a bit complicated, but they're not really that complicated. It is that mu is then the average, so that's the little Greek U with the dropping bit on the other side. That is the average number of goals scored in a game across that season's data.
Yep.
We have for the home team, their rate of scoring goals, that's the top one.
Yep.
So we have the average number of goals plus the home team advantage.
Right.
So we know that there's a home advantage in football. This allows to adjust for the home team advantage.
So they just get a little boost for being a home team. Same for everybody.
Yep,
so
and you can see the away team doesn't have that.
No.
So both of these equations are going to give you the rate of scoring goals for each of those two teams. And already, using just those terms, say the average and the home advantage, we're going to get something happening in the season. Again, it's going to lead to odd results across the season because it's not taking into account each team. It's just an average sort of thing. What Maher kind of expanded upon the kind of really basic idea is this difference between the attack and the defence of the home and away teams. So we have kind of an adjustment to each one of those equations on the basis of how strong the attacking of the home team is and the defending of the away team is. So taking the difference of those two things is what gives the adjustment to the home team's scoring rate. So if the home team has a really strong attack, the away team has a really weak defence, that means you'd expect the home team to score more goals.
Yep.
And the same thing in reverse for the away team.
Yep.
The away team's got a strong attack, or if the away team, say, has a weak attack, the home team has a strong defence, you would expect that number to be below the average number of goals. So you're going to
it's going to drag you down.
Going to drag it down slightly.
Yeah, so we've now got, and I think, so I'm familiar with this this paper. Love it.
I'm glad it was the model you were thinking
others,
of.
yeah. But there's some other paper, and they say basically that if you're trying to model goals in football, the nature of football is such that the number of goals I score should be some function of my attacking strength and my opposition's defensive strength.
Yeah.
And so here it's just looking at a different, so some way of measuring my attacking strength and your defensive strength, and then just look at the difference between those. And like I say, if my attack is better than your defense, then that'll give my little goal scoring rate a boost. If my attack is worse than your defense, then that means I'm not going to be able to get past you, so it sort of drags me down a bit.
See, as a model, it kind of makes perfect sense.
It makes football sense, I think.
It makes football sense.
The
difficulty is fitting it to all the data.
How do you calculate my measure of attacking strength? That's going to be
That's what the paper is all about, really, is about how to calculate these actual values.
He also did a ton of work on whether all these things should be team-specific or not, like you've been alluding to. Yeah. So you said the simplest one is we just treat it the same for everybody, but you could have also had a specific Leeds United home advantage, because you'll always hear pundits saying coming to Ellen Road is, it's a thing, it's difficult. So he looked at that, whether it's worth actually estimating a specific home advantage for every team, and found no. And really experimented with exactly every single thing in here. As we keep seeing on the corridor of uncertainty, don't just kind of assume, really let the data tell you whether or not you need to have a specific Leeds United attack, or is a home team attack enough, and all this stuff. So he did loads of work on playing with every single personalisation of these parameters, and this is what he came up with as being the best, nice balance between kind of personalisation, but then not going too far with it.
So just to be clear, the ln on the left-hand side, if you're not familiar, is the natural logarithm. In this case, this is just to allow the fitting to be more straightforward. I believe it's just sort of to do with the way that the package I'm using works to make the fitting more straightforward, but it also makes the equations easier to read, I think. So Maher's is all factors, isn't it? Multiplying each other. This is easier to read, I think, this way. Yeah. So the package I used to work with this is a fantastic package that's free to download on R called Goal Model, or Goals Model, by somebody called Jonas. Their name that's the only name I could find on them, but thanks to them for creating this package.
One name. Yeah.
Very easy to use, straightforward to set up as well. So really, and quite well written as well to actually understand what it does.
Cool.
So I used that package to look at the 25-26 Premier League season. So 309 games up to the 22nd of March. So that was the last game before this little break.
Yep.
And fitted on the basis of that. So this diagram here is what we see, the what did you call it? The outcome table?
A sample space
diagram. So this is essentially that. So for the double Poisson model, so we can see we've got a little grid of results. Down in the bottom left is 0-0. This is Arsenal versus Man City, or Man City versus Arsenal, from the 19th of May, which is, everybody is hyping as a big game for the season.
So you're trying to predict the one that's going to happen.
Yeah.
We've just seen them battle it out at Wembley. Yeah. And we saw what happened there. But this is Premier League. They're going to play each other.
That result is not included in this. I've only used Premier League data to fit this.
Which one? I should know the answer. Which is the home team?
So in this case, Man City across the bottom of the home team.
Yeah.
That is just the way I've represented it in the graph. Not necessarily.
So that if we're saying there's a home advantage, I'd expect them to have a bit more darker red colour.
Yeah, so the darker red is the higher probabilities in this case. They're all probabilities, so they're numbers between 0 and 1 for each outcome. But you could say, in this case, say a 1-1 draw. We can go up across Man City 1, Arsenal 1, 0.1, about a 10% chance of a 1-1 draw.
Okay.
So equally, though, about a 10% chance of a 2-1 Man City win. Or a 1-0 Man City win is around 8% chance. So all of them individually on their own are quite low.
Yeah.
Because the outcome is not set. It could be a lot of things. There is also 98 point something percentage of all of the outcomes are covered in this graph.
Yeah.
Because it does simulate up to 25-0, which is very, very unlikely. I think it was around a 1 in a billion chance to see like 12-0, which would be very unlikely. Man City Arsenal being a 12-0 would be very surprising this season.
We can already see on your top row it's saying it's basically 0, but
very small probabilities of like 5-0s and 5-1, these sort of chances. But we can see from this grid kind of what we expect to see happening.
So if I wanted to know the probability of a draw, that would be adding up all those probabilities on the diagonal. Because again, we're in GCSE maths.
Yeah.
It's a draw is a 0-0
or a 1
Yeah,
or a 2. And when it's an or
Yeah.
of 2, then we can add them up. And then similarly, if I want to get
Yeah,
Arsenal winning,
win.
that would be the top part, the
above the
top
diagonal.
triangle, and then the Man City winning will be the bottom triangle. So you could add up all those numbers.
Yeah.
That would give you an estimate of Man
Yeah.
City.
So I didn't do that because I don't want to encourage anyone to bet on these results because, we'll talk about that in a moment.
Okay. But we could do that. That's how we could predict.
That's how we could predict individual game outcomes, definitely. Okay. Yeah. So part of the problem is this model is called the independent Poisson model. You know, that's its thing. It's 2 different Poisson distributions multiplied together, essentially. But goal scoring is not independent. You know, when one team scores, the other team can't score at the same time.
Yes.
This process is inherently assuming that the 2 processes are happening independently. They're not. Football is not independent. There are 2 teams on the pitch at once.
So I was saying it's like GCSE when I had my coin and my die.
Yeah.
Those things are independent. What happens on the coin doesn't impact and that's why we could add these things or multiply these things and get these probabilities. But football, it's not the same because, like you're saying, you can't. Yeah.
And so one of the issues with this model is that if you look over the course of a season, it doesn't predict enough low-scoring games.
No.
And it doesn't predict enough low-scoring draws, I think, as well, or maybe too many draws. But basically, over the course of a season, you don't quite get the exact results you would want. Okay. One individual game, it's hard to say because, you know, you're predicting one outcome.
Lots of noise.
Man City versus Arsenal, if it's 2-1 versus 1-1, the model is equally confident in either one. So, you know, obviously those are very different results for both teams. But what then some new people looked up, so Dixon and Coles, 2 different mathematicians that Jess is very familiar with, they did a paper that was actually about betting. So this is why I was saying we're coming back to betting, is that they were talking about exploiting inefficiencies in the gambling market or something like this.
So it's exactly the question I was asking at the start, which they were sort of thinking, can the university lecturers beat the gambling industry? You know, I'm a mathematician. They were mathematicians in a uni. Can we beat them? You know, because with all our resources at our disposal. And so, that's what it's in the title. They're talking about it. And I think the version is that they thought, actually.
Yeah, so they said maybe we could.
Yeah. And then they're now no longer work at universities.
So they went off to start sports information companies, which probably work with gambling companies. So this is the point about beating the bookies, is maybe you could back in 1996 when they published the paper. Now they've read the paper. The gambling companies are using this method plus all the other things they've developed since then.
Well, one of our colleagues runs student projects doing this sort of thing each year. And he says that when he started doing them, that the students could build things that beat the bookies. So they did a better job, but not by more than the bookies' margin. So it's not actually profitable. But then he says, but what's he been doing? He's been training up graduates who've then gone and worked for these gambling companies, so you can't even beat them by that much
Well, I think
anymore,
that's always the thing, is the bookies, you know, the house always wins. They always have a way to think about it. Yeah.
But the thing that I found interesting was that they are... I wondered if these were 2 separate worlds, like universities and bookies, but... When you think about it, of course not. It's actually graduates go work for them, so they're very aware. They're very aware of what's going on, and so if a paper like this came out now, they'd see it and they would just be like, okay, and
So what Dixon-Coles did was addressing that issue of, well, part of it was addressing the issue of those low-scoring games. So addressing like this, basically these bottom 4 squares. That's all they adjusted. They introduced a term called the independence parameter, which is ironically really the dependence parameter because it's removing the independence.
Okay.
But they introduced this independence parameter that addresses basically the bottom left corner. So 1-0, 0-1, 1-all, and 0-0. And it increases the odds of 1-0s either way, decreases very slightly. On average across the whole season, will increase the odds of 1-1s slightly, decrease the odds of 0-0 slightly, I believe. 0-0 and 1-all slightly, I believe. But not by much, and by varying amounts depending on what they are, especially with home advantage, you know, it's going to bias towards one way or the other.
So so what you said was we could use a Poisson distribution to help us predict these score lines.
Yep.
And you showed us the graph and you were like, it's doing a pretty good job. And basically what they've done is, can we move things around a little bit, tweak it a little bit to try and get it a bit closer to reality?
They are just, tinkering at the edges of what is still using the double Poisson underneath, but always adjusting it slightly on the basis of that bottom left.
Yeah.
Basically, those bottom left 4 squares. So they also introduced a factor for time weighting results. So this is just that when you're fitting your parameters, when you're doing, allowing what the computer does for you, fitting the parameters, going back a long way, the games at the start of the season matter less to the ones that happen more recently. Because that kind of makes sense. The games at the start of the season do matter less to ones that happen more recently. So you do want to take that into account slightly. It's not a huge weighting, but it is in there as a parameter.
Yeah, because I think we always say, and I think this is something that, again, people remember from school, like more data's better. The more data you can have, the better. But yeah, you might think, right, use every result ever for Leeds to try and get their attacking parameter. But yeah, what Leeds were doing in 1972, sadly, is not that reflective of what Leeds are doing these days.
Yes.
But actually, there sort of is information in it, but what they're saying is, okay, let's take a little bit. Let's really, when we're building the model, we actually won't treat all observations equally. We will say recent results, more informative, past results, less informative.
Yeah.
Still let them all have a chance at informing the model.
That's exactly it.
So, yeah, cool.
Yeah, so what I did is I refitted the data from 25-26 to 22, up to 22nd of March, refitted it again, and then I've now predicted the Man City Arsenal game again.
So you did
using Dixon-Coles.
Using both, so we take the 2 independent Poissons, you've got your little correction, and you've done the time weighting as well.
Yep.
Wow.
So this was the time weighting as well.
And this is all in an R package.
Oh, text. Yep. Literally seconds in an R package.
Right.
So you can see this change in results that's happened. It's not dramatic, but it might work over the course of a season. So as I was saying, even though the Dixon-Coles adjustment probably down rates the chance of 1-1s, in this case, it's actually upweighted it.
Oh, okay.
So just because of, over the course of the season, it's perhaps seen that Arsenal are very good at getting 1-1s, and maybe that should be more important to kind of weighting those factors, those attack and defence factors. But yeah, you can see it's made a slight shift in that now it's most likely to be a 1-1 draw.
Yeah, because it was 10% before, wasn't it? And now it's come up a little bit. Yeah. Okay.
So generally, the fringes are not adjusted too much, but it's that little square in the bottom left has had a bit more of an effect, and it's adjusted it a bit more to being a 1-1 draw.
And it's got to all add up to 100% because it's a probability. So it's like using your limited budget, where can we move things around a little bit? Okay, got it.
Yeah. So
if one has gone up, something else has gone down somewhere. Yeah.
Yeah. So that's just predicting one game. So obviously now we can predict one game.
Yeah.
I can predict the rest of the season.
Okay.
So there's 17.
Tottenham getting relegated.
So seven games left for most teams, 8 for Arsenal and Palace. But so what I did is I ran the rest of the season 10,000 times.
How do you do that then?
So literally just very quick, just take the probabilities and resample the ones for each result.
So that little table that we've got, you get that and then you go...
Pick one. You pick one with a weighted random choice.
Right,
so you pick, say, which, on average will pick to the most likely one most of the time.
Yeah, but like we saw with Darren Brown, sometimes it would pick
sometimes
up 5-0.
It will pick a 5-0.
Yeah, okay.
Yeah, so we will pick some rare ones sometimes.
When people say they've simmed the season, I always wonder what that is.
Yeah, so it takes literally seconds to do.
Right, okay.
So as I say, it takes about 2 seconds to run 10,000.
10,000
iterations of
the rest of the season.
Yeah.
Wow.
And then
excellent.
taken the average positions of these teams, or what percentage of the teams, what percentage of the time they achieve the position.
So you 10,000 times.
Yeah. Calculate.
You get all the results, and you make a table. So you've got 10,000 league tables.
10,000 league
right,
tables,
on average, where is everybody? Okay, come on, tell me.
So,
where are Leeds?
So let's look at the sharp end first.
Excellent.
So the sharp end, we see that Arsenal actually have a very good chance of winning.
Yeah, but
the
no
league.
one really cares about who's winning the league, right?
So 92% chance. So Arsenal fans could probably breathe easy. Around a 93% chance of winning the league. So 93% of the time in my 10,000 runs of the season, they win the league. So pretty dead on now. 6% of the time, Man City win the league. Arsenal end up second. 6% though is above what we would say is statistically an outlier, wouldn't we? It's not 1 in 20, so it's slightly above that. So it's not unlikely for Arsenal to not win the title. It isn't there, so you can still be a little nervous if you're an Arsenal fan.
Well, I'm sure they will be.
But Man United, no chance now as well. And it's interesting. So those top 4 kind of nailed on in the chance positions they're at.
Yeah.
That you can see. So anywhere it's dark, the darker it is, the more likely it is to be in that position. You can see we've got the top 4 there. Then there's a big blob in the middle between Liverpool and basically Palace.
Yeah, they're just
huge blob with a lot of uncertainty as to where they're going to finish.
Who you're going to be in,
And I think that's kind of reflecting the Premier League this year as well. All of these teams have managed to get things on their day.
Yeah,
so
and the points are really close.
Yeah. So there's a 2 in,
and a win would really
2 in 10,000 chance that Chelsea actually finish up second. And Palace, crazy, can go 2 in 10,000 chance that they can actually finish up in the Europa League spot in 5th. Or a 4 in 10,000 chance, so 1 in 2,500 chance that they get relegated. So, Palace's form. I think that's kind of reflecting the Palace's form across the season. It does actually reflect the uncertainty. So you can see really broad bands for some of these teams.
I love that.
Obviously, very small chances.
Yeah. The the year that Leicester won it.
Yeah.
Fans had banners saying we are staying up, in the stands, which I absolutely loved.
So that's
what
Palace
would be doing.
Banner, So they've got about 40% chance of finishing in 14th, I think, where they currently are.
Yeah.
So most teams, the highest chance is where they are currently because that's the result of quite a lot of games. So kind of expected.
They've played all those games, and you're just saying how could the last 7 impact it? So you would say it shouldn't be that much, right?
So let's look down at the bottom.
Okay, well, this is the moment we've all been waiting for.
From Jess's shirt, you can see that she's going to be nervous about what's going on. Leeds, about a 7% chance of going down. So it's quite slim. And that kind of reflects, I think, that other teams are playing badly too.
So it's only a bit more than Man City's chance
of winning the league.
Yeah.
But I wouldn't put money on both of those outcomes.
Yeah, I would think that Leeds are more likely to get.
Yeah, well, it's because the other teams are also playing badly.
Yeah, that's true.
That's the thing. So,
you've not got Spurs in there though. So but you have got West Ham.
West Ham most likely to be relegated. So first off, Wolves and Burnley. Yeah, you've got a 0.1% chance or 0.04% chance of staying up. It's very unlikely now.
Yeah,
nailed on basically for relegation. Both of those. It's around 3rd for West Ham and Spurs. 30% chance. Well, 34% chance for those two. That's quite likely for either one of those teams. Slightly more likely for West Ham. But I would say those, there's about 0.5% difference when I rerun this model over and over again. So there is a bit of variation in this 0.5%. But yeah, it's bad news for West Ham, bad news for Spurs. You should both be nervous. But yeah, so I can't tell you which one of those two, but it seems likely that one of those two. There does seem
to be a bit of a jump between them and then Notts Forest.
So Forest is about half as much. Leeds about half as much again.
Yeah.
And then, as I say, Palace even have an outside chance, but seems very unlikely now.
Yeah.
But the Spurs one, maybe, is a slight bit of good news is they've got rid of Tudor now. So we'll have a look at that in a future video on how Tudor would have done this season. But
I saw a good talk somebody did about sacking your manager and whether that's a good thing or not to do.
Well,
I mean, those two teams right next to each other, aren't they? Notts Forest and Spurs are really testing
the theory on
theory, nice
whether there is a new
comparison.
manager bounce. They're both hoping for one constantly, apparently. But yeah, so that's my outcome of 10,000 runs of the season. You can see that pretty much nailed on that Leeds are going to stay up.
Come on.
But not in the outliers.
Although my family, we're all Leeds fans. We were talking about this. We quite like being in the Championship, winning all the time.
Yeah.
And my mum was referenced Colin Sky Sports Leeds TV because we're on every week as the Championship game.
Championship game, yeah.
So actually we're on quite a lot when we're in the Premier League as well. But so, yeah, obviously we want to stay up, but I try and see the silver lining. But this is looking really good. We're totally happy with that. And let's have a think then. So the last 2 years, all 3 promoted teams have got relegated. But actually, that's saying that only one of the promoted teams is likely to get relegated.
It seems unlikely this year. It has for a while.
What's Sunderland got to do?
Sunderland, Newcastle both have got huge range as well of outcomes. Newcastle as well. It kind of reflects the way their season has gone. That Newcastle sometimes win a game you never think they had a chance, but and then sometimes they lose a game that you think they would have won. So kind of reflects that uncertainty with this big range that I do think reflects this season's Premier League.
Yeah.
So we will see how I do. And maybe if you come back in June and I've been completely wrong, you can criticise me in the comments. But other than that, we will see you later.